All right, graphs and displays, very important, but the nice thing is, like I already said before I started the recording, is that a lot of you, especially if you've gone through Algebra 2, have seen a good portion of these already. We may add some things to it, and then eventually, if you behave very well, I'll show you how the graphing calculators will do pretty much all of this. Okay, so ways we can display the data. One of them is a stem and leaf plot. And there's many ways you can do a stem and leaf plot, believe it or not, and there are sometimes what are called a back-to-back stem and leaf plot, and we'll kind of maybe discuss that once we get going. And then sometimes you have two stems for each leaf and whatnot, and we'll talk about that as well. But again, you can always paraphrase these, get down what you need. So obviously it's a way of displaying quantitative data, set it into some number of stems. And it's the leftmost digit or digits, and then a leaf that goes with it, which is the rightmost digit. And we do have an example that's coming up. Don't get too far ahead of me because seeing I know most of you already know how to do this, we're going to cheat just a little bit on making it because we're not going to take our time to do that right now. Perhaps I'll have you do one on the homework, and that'll be enough. Because again, I know you know how to do this. All right, how are we doing on our definition? Good. So again, the stem is the leftmost digit or digits, depending on how many digits are in your number, and then the leaf should be the rightmost digit. Okay. Everybody good? You can always come back to it if you need it. So what you see here is the following are numbers of league-leading runs batted in, otherwise known as RBIs, for baseball's American League for the last 50 years. But this is about 10 years old. So this is the league leader. So you can probably find the strike year in there for the runs batted in. It's the league leader. Yeah, the 78 is probably the year that they had the strike. Right? Display the data in a stem and leaf plot. Okay? So look at your data. What do you believe would be good possible values? And we're going to write it over here on the right-hand side. You know I have the kind of the little crosshairs over there started, or the T bar, whatever you want to call it. What would be a good stems to use then based on the data that we see? What would be probably the first stem? A 7, very good. Because remember, you can use, in the stems, you can use one digit or multiple digits, correct? But then in the far right, you have to have many. So then we would probably go to, we'd have to hit probably 8, right? And then 9. Even though there might not be any of that data there, we should probably still put that in, okay? It would probably be best to do that. So now what? How do we get the hundreds then? Yeah, we throw a 10 here, and then you just kind of, normally you would make some kind of legend when you're making this and say like 7-8 equals 78 so that those people that are reading it know what in the world's going on. All right? So I think we're probably fairly good with this, correct? Okay, so we're going to cheat. Okay, there's your answer. You can write it down if you feel you need it, but I feel very confident that all of you can make a stem and leaf plot. Correct? Okay, so write down what you need. If you ever want to see this again, I can show it to you. Or if you're listening to the recording, of course, you could pause it at this time. Okay? But I am going to actually take this time to talk about other things. Okay? I mentioned earlier the back-to-back stem and leaf plot. Does anybody believe they know what that would be? Any ideas? Very good. We have another basically leaf on the other side of the stem, right? So maybe this over here would have been the last 50 years, and then this over here would be the 50 years before that, right? And then we would put those values over here. Those would be back to back. Do you see how that would work then for a back-to-back stem and leaf? Okay. And would that be a good way of maybe comparing those sets of 50 years? It very well could be. And who knows what that could be? Because now you're starting to get back into some very different times in baseball. Okay. So That's a back-to-back. Another thing they might ask you to do is have two parts for each stem. So here you would do a 7 and a 7. This first 7, you would basically put 70, 71, 72, 73, 74. And then in the second one, you would put 75, 76, 77, 78, 79. When would something like this be very helpful to have two of them like that? When the data is very scrunched together, right? What if all you had was 70s, 80s, and 90s? Would doing 7, 8, 9 be very helpful? Not really. So you would split the 70s into two of them. You'd split the 80s into two of them. Split the 90s into two of them. Is that a good idea for the data we have here? Not for the beginning, maybe in the middle, right? Look in this middle. Would it be very helpful there? Yeah, but you don't just start deciding to do it halfway through. All right, you make it one way and stick with it. Okay? Is that good? Make sense? Okay. There was a hand up. Yes. Oh, I answered it. Can you like halfway through split it up? Probably shouldn't. Okay, we would like the data to be consistent all the way through. Kind of like we tried to make our class widths all the same, right? Try and keep it consistent. So any questions on the multiple ways you, or multiple variations of the stem and leaf? No? All right. A dot plot. Again, you've seen these before. And again, we will do as much of it as we need to. Again, it's quantitative data.
Excuse the interruption at this time. 10.
Okay, and we heard there that the sophomores are getting called down for pictures. So it's quantitative. Each entry is plotted using a point above some kind of horizontal axis. Again, this would be a good horizontal axis. You see example 2 here. If we're going to go back to that data from example 1, we would probably start with this. The nice thing about this is you don't have to worry like about a broken axis and say, oh, 0 would be over here and break it up. You just need to make sure that you have the data covered with your horizontal axis. Okay? And then all you do is you go ahead and you find, well, we know 78 was that strike year, right? So here's 75 would probably be right about there. So you find about where 78 is and you kind of put a dot above. But what do you do when values repeat? For example, it looks like 109 repeated, what, 3 times, I think? So what do you do there for 109? Well, let's find out. Well, 109 probably goes right about in there, right? So how do you represent that it has 3? 3 dots like right on top of each other? Or how do you do that? Like there's 1 dot. Where's the next one go? Yeah, just keep going above it, right? So it goes something like that. And if you had more, you just keep working your way up. Okay. I hope you're okay with that's all I'm going to do. I mean, I could just put a bunch of dots up there, but I think we all could handle that, right? Given the time, I'm pretty sure everybody in here could handle making the dot plot. Okay. So based on the 2 so far, we've done stem and leaf and then the dot. Do you possibly view one more helpful than the other? Anybody? Think stem and leaf is better? Why do you think that? The actual data, okay. Where here you kind of got to interpret what that data value ended up being, right? Because depending on how many tick marks we put in there, maybe one of you might think I just graphed 108 instead of 109, okay? Any advantages to the dot plot then? Because that's kind of a disadvantage to the dot and an advantage to the stem and leaf. Can anybody do it the other way around? An advantage to this one? Okay, easier probably to see how many of each one. That could be, right? And then which one's probably the greatest? It's probably easiest to see, right? A little bit quicker than the stem and leaf. Because let's face it, they both take about the same amount of time, right? It's not like one's quicker than the other, okay? So I would go along with your answers there. Very good. The next one, pie chart. It's basically a circle graph that will show the relationship of parts to a whole. Okay. So here in example 3, we have the number of inner city passengers in millions traveling by bus, air, subway, and Amtrak in 1995. Again, this is actual data. Use the pie chart to organize the data. Okay, so what does this mean right there again? Sigma means sum, very good. So how do we have, well, actually that turns into a billion, right? If we have 1,000 million, right? So 1,229,000,000. So how do you have a 0.4? Yeah, because it really means 400,000, right? And plus, you know, does that make sense to everybody? And maybe sometimes this will happen like a 0.4 of something if you're doing an average, but that's not what's happening here. It actually means 400,000, right? So I don't think you have 4/10 of a person. So how do we do relative frequency again? That was on our homework for yesterday with that question that was unfortunately wrong. They did it backwards. How do we do it again? Take the frequency of the class divided by the total, right? So for this first one here, relative frequency for bus, we're going to take the 359, which is the frequency for that class. That's how much of the data fell into that class. And we're going to divide by the total of everything. Now the question is am I allowed to do it like that, or do I have to put all the zeros in for the thousands? I can do it like that. Why is that? Because basically all those zeros would cancel anyways, right? So let's be smart and not actually type all those into our calculator because we don't need to. Now, I don't know many of us that know this off the top of our head, but we could probably get close, right? Because it appears to be about what? About a quarter, right? So we should get pretty close. And what'd you find out? Anybody actually get that decimal? Let's go to 3 decimal places. That's not what's written. Yeah, 0.292 is what's written on mine, yeah. And again, you're all very smart in here, so I'm pretty sure we could all do that division on our own, correct? Is everybody okay if I just take that little rectangle away and you write down the answers? Is everybody good with that? Okay. Now this is slightly rounded, I believe, correct? Or is this coming out exact? Anybody? Well, one way to check it is to actually add that up. Actually, this might come out pretty close. If I add it up, it should come out to really close to, depending on rounding, it should come out really close to 1, right? Because we're talking about 100% of the data. It is 1? Yeah, I think. Because of all those zeros, I think this one came out pretty close. Yeah. So how would we translate that then into some kind of angle for a pie chart? This right here is the percent of the data that it represents, correct? And all of it added up is 100%. So if we're talking about a circle, what is 100% means 360 degrees, right? And so what we would do is say, well, I know 360 degrees is the total. I know basically 29.2% of it has to be for bus. So what you would basically just do is take 360 and take it times the 0.292, and that'll tell you how many degrees you should set aside for the bus. Well, when you actually make a pie chart, yes, you are actually going to have to get a protractor out, and you are going to have to measure. Okay. Oh, you will in here, yeah. Not right today, but I'll just do one on the board to show you to make sure we all remember how to use the protractor. All right. So what is this value for this first one? Somebody actually figured out, or I'm not going to uncover it. So somebody actually figured out, we'll do nearest degree, I think should work. 105 degrees is correct. So your first one's 105 degrees. Is everybody clear that they would know how to make that calculation on their own and I can uncover the rest of them? Yes. Okay. And again, if we add those up, depending on rounding, we should get not 1, but kind of the circle's version of 1, right? 360 degrees being the whole thing. And once again, the beauty of having this being a junior and senior class predominantly is that a lot of you have seen a lot of this work before with the protractor and various other things. And that's some of the reason I'd prefer students had Algebra 2 before they took this, but you don't have to, and geometry as well. Is everybody good? Got it written down? So we know the first one's 105 degrees, so okay. So you got your circle. All right. What you basically have to do is pick a starting point. Okay. Now, in this particular year that I'm teaching it, a lot of you have had advanced math, correct? So probably your starting point's going to be right there, which is the standard position where we started from in advanced math. You don't have to start from there. You can start from wherever you want. And then what you have to do is many of them have, uh-oh, I broke it. Oh, there we go. Oh, that's why. There's your answer. Go away. Okay. So you put it right there. You line up that bottom piece, and then you got to find 100. And so you're starting this way, so you're adding up this way. So you keep going, and pretty much until you hit that, what was it, 105? So there's 105 degrees. You take away your straight. Whoa. Having issues today. Take away that. Use a straight edge, of course, and mark it up there. So that is, what was it, bus? Is that what it ended up being, right? So bus, and then a lot of times you put what the percent was, and we'll bring this back. This is a nice new feature I like, though. I like having fun with that. 29.2% bus. It was hidden, but unfortunately I put the protractor right on top of it, so when I tried to move the protractor, I brought this up instead. I forgot that it was over there. Sorry. So one very nice way of this is you can compare them quite easily, right? You can see them nicely next to each other. Let's face it, if we see percentages, we can tell, but now when we see it graphically, we can tell that Amtrak is a very small sliver compared to the rest. Okay. And what does it mean, intercity passenger travel? We should probably make sure you understand what that means. We talked about inter as a prefix before. What does that prefix actually mean? Inter. Nope, not within. Inter, believe it or not, is a prefix. Actually means between. That's why it's called an interstate. It goes between states, like Interstate 39. Okay. So between cities, now does it make more sense that you would travel by air? I'm hoping that if you thought it meant inside of a city, you didn't think they were flying from one part of the city to the other. Unless you're really rich, right? You could have a helicopter, perhaps, but that would be about it. Now it makes a little bit more sense. Any questions on that one? Yes. Oh, you're stretching? Okay. All right. Paired data sets. It's still going to be almost all of our data sets. Are two data sets, or multiple ones, that have the same number of entries. And each entry in the first one corresponds to one in the second one. So this is basically your XY table is one very good example of a paired data set. Like if I gave you a function and said make an XY table, there's a paired data set right there. You got an X that resulted in a Y. They paired up, right? So this is very wordy for saying, you know, two sets of data kind of go together. This set and that set work very well together. It doesn't have to be an input and a response like it would be for a function, but a lot of times that's what people would think about. Okay, everybody good with a paired data set? So that's kind of, you know, we've graphed lots of those throughout your career here. Scatter plot, you probably haven't graphed very many of these, but we are going to graph a lot this year eventually. Not for a while though. It's a graph where the ordered pairs are graphed as points in the coordinate plane. They are not connected. So it's not like we're graphing a line necessarily or a parabola or anything like that. We just have a bunch of data points. So for example, if we had a bunch of data, we would just kind of do this. Again, this would have to be paired data, right? There'd have to be an X and a Y to go together, right? Well, we would not necessarily connect them. They would just be scattered, hence the name. Yes, we will eventually find a trend line or a best fit line, and we will do it a little bit more exact than it's done in Algebra 2 here. We will truly find the best fit line. Questions on that? Pretty straightforward, right? Once again, I'm pretty sure we can all handle this one, right? Just graphing a bunch of points. Okay. I'm hoping they're in there, but they're not. Oh, there they are. Okay, so you would graph them. There you go. You don't connect them, right? So you can take your time and graph them later, or graph them now, whatever you want to do. But probably the hardest thing for a lot of people is setting up their axes of what label they should be. So you'd have to take a look at your max and your min and make sure they're all covered. Try and go up by a steady increment so that it does not get skewed any particular way. Any questions on that? Again, I think we're all capable of making that graph or that display. Everybody good? What's that? Well, it's up to you if you actually want to do it. I'm pretty sure we can all handle it. Yeah. All right, 2 left, we're done. You have to add one. Oh, well, you'll figure it out. Okay, time series. Find some room for it. Whoop, typo. That's okay. It's a data set that is composed of entries taken at regular intervals over a period of time, not period O time. Could be every year, every 5 seconds, whatever, but it would be a regular interval. And then Pareto chart is one that I see popping up a whole lot more. I never used to really cover this one very much, so this one was added about an hour ago. But it is popping up more. It's very simple to do. It's used a lot in business. It's long, but it's quite simple, so you can definitely paraphrase this one by any means you need to. But the definition was kind of hard for me to come up with because the book didn't have a very good one. Vertical bar graph of frequencies or relative frequencies where the bars are positioned in descending order based on height. So the most frequent would be first, followed by second most, third most, so forth, and so on. So basically take your frequency histograms that you've had, and you have put them in some kind of order on the bottom already, based probably on the order that the classes came, right? So what you would do here is you would jumble it up based on which one had the most. And I can give you an example here in a second. So this one over here that I'll do first would be, for example, your frequency histogram. So let's say at whatever number 1 is, you had 2. At 2, you had 6. At 3, you had 8. And at 4, whatever that is, you had 4. So what do we got? 2, 6, 8, and 4. Is that a Pareto chart? No, that's just a frequency histogram, correct? Can I change my frequency histogram quite easily into a Pareto chart? Okay. The reason some people don't like this is what really happens. Your horizontal axis could possibly get jumbled up, correct? So in what order should I put? Because these are still 2, 4, 6, 8. Agreed, your vertical doesn't change. But does my horizontal change? Yeah, what should go first in my horizontal then if I'm going to make it Pareto? Yeah, you're going to go 3, followed by 2, and then 4, and then 1, right? So 3, then you would just go and make the same thing. You would just go up to 8, right? And then for 2, you'd go up to 6. 4, you'd go up to 4, and 2, right? So that's the Pareto right here. So can you see why that would be important in business? Yeah, because this could be just the quarters, right? First, second, third, fourth quarter of a year. You're going to put the one that you did the best in probably first. So apparently third quarter, this business did 8 of something. I don't know what. But that could mean they fired 8 people, right? We don't know. But, or they made $8 million, right? We don't know what that means because we don't have them labeled. Okay, but that would be Pareto. Okay. Questions?